Hello, my name is Petri Suksdorf and I'll be going through the first part of this presentation from Group M, which consists of members Juho Lepistö, Tommi Ouramo, Roni Rönkkönen and myself. After my introduction, Tommi will go through the improvements of the construction. After that, Roni will talk about numbers to justify the improvements, and then Juho will talk about how the project could be continued if more time would be used on this project. Our chosen product for evaluation is a Wilfa Moist S air humidifier. It converts liquid water to water vapor using ultrasound. This humidifier 20 watts of power and converts 2.3 liters of water to vapor in 10 hours. This product was chosen for evaluation because it has an interesting sub-assembly structure, and the improvement of this product seemed challenging for us. For our analysis, as critical components were considered those which either stop the working of the product or put the operation of the product at risk. For example, if a fan is missing, the components can overheat and break. Also, if the fan malfunctions, a total failure is inevitable. Components that are not considered critical are, for example, a lid strap that, when missing, only affects the user experience and not the function.
This slide consists of the main improvements which are made to the original product. When looking at the shown figure, it is relatively easy to decide first improvement target. Reducing the number of components by integration was one of the main targets when defining a new design for the components. The original construction had, for example, lots of different screws for fastening other parts. Some of those screws were even manually cut to correct length, which is unnecessary action, of course. We wanted to reduce also the number of screws and standardize the rest of those. Original product broke down after it was used only less than a year. Reason for that was that during the maintenance operation, some water went inside the product and caused a short circuit when the machine was started. The marks of the incidents can be seen on the bottom of the outside surface of inside capsule. This human error can be partly prevented by changing the location of electrics inside the machine, which will increase safety and make machine more resistant to this kind of errors. All suggested design changes are aiming to affect positively to the efficiency of assembly and improve the manufacturability of the components as well. The need of different component items is reduced, and the product cost efficiency should be better. Visual outlook of the product will change a little bit due to these design changes. This can cause some discussion: is the product model still same, and will it still represent Scandinavian design style as the original product?
Numbers to justify the improvements of the product. This product is divided into 4 sub-assemblies, so I will talk about the sub-assemblies first and then some all results of main assembly. The capsule sub-assembly had 24 components in the old design and 12 in the new design. This reduced the total number of components by 50%. Also, the sub-assembly time dropped from 120 seconds to 75 seconds. The reduction in the number of components was due to the integration of components so that they could be manufactured by single injection molding. In the design of the lid, the main difference between old and new design is that the new design does include only one component, meaning that the number of components was reduced from 7 to 1. This means that the number of components was reduced by 86%, and this change has great impact on the assembly time because instead of assembling 7 parts together, the lid is ready after one injection molding process. It means that the total assembly time related to lid dropped from 31 seconds to 2 seconds. Assembly time was reduced by 94%, which is impressive result. In the sub-assembly of the water tank, only non-critical components is removed, which reduces the number of components on the sub-assembly from 7 to 6, which means 14% less components. Manufacturing time of the cap sealing the water inside the tank is reduced significantly from 87 seconds to 22 seconds, which means 74% less time by skipping pull removal completely. Some excess material will be left on the cap where it's not critical. Sub-assembly of inside capsule where discrete quantity of assembled components in the module easily by removing separate fixing components and integrating different components together. This reduced the components from 32 to 22, which is 34% less components. This also had positive effect on the assembly time at the same time, and with old design assembly time was 358 seconds and the new assembly it's only 276 seconds, which is 23% less time. And few words about the main assembly. In the entire manufacturing process of the product and in the number of components, this means that the total number of components decreased from 70 to 41 components, which is 41% less components. In the old design, the total assembly time was 542 seconds, while in the new design it's only 371 seconds. Product assembly time was reduced by 171 seconds, which is 32% less time. The total number of critical components of the product changed slightly from 24 to 23 components because critical components couldn't be removed or integrated. Overall, the results show that the new design is significantly more cost-effective than the old one, and based on the numbers we have been able to significantly improve the product.
If we would have more time to continue our project, we would have integrated the sustainability aspect more to our project. We could have used the life cycle assessment analysis from cradle to gate, which means considering the material production, the product manufacturing and processing emissions. And we could have increased the sustainability by using the biocomposite, bio-based plastics, or wood as an outer shell of the product, as for example. We could have integrated the more components and by increasing the function of the single component. We could have also analyzed the product concept and the function of the device more deeply. In cooperation with the product designer, we could use or change the visual outlook of the product more and reorganize the components inside the product. This would lead to the decrease of components. Also, in cooperation with the electronics, we could reduce the quantity of electronics in the product. This could lead also great decrease of fixings in the structure. Thank you for your time and please send questions if there's anything unclear. Thank you.